Hello, since I'm not able to be there in person, I thought I'd introduce myself a little bit. I'm an automation engineer at Marvin Windows and Doors in Grafton, North Dakota. Been with the company for 5 years since I graduated from University of North Dakota in 2015 with my bachelor's in mechanical engineering. Currently pursuing the Master of Engineering degree in mechanical from Iowa State. Looking to graduate here in December of this year if everything goes as planned. To introduce my project a little bit, since I am an engineer and working in industry right now, I tend to lean more towards application-based projects, a little bit less on the research side. And I came up with this idea from the fact that I do a lot of shooting for rifles and pistols, and I reload my own ammunition as a hobby. So when you shoot a lot, you end up with a lot of spent brass cases, and they end up in mixed buckets, and eventually they need to be sorted out so that you can reload them with new powder and new bullets. And it's kind of a tedious process, so I would like to automate this process using vision guided robotics to pick and place the cases into sorting bins. This can be done in a number of ways, but robot and machine vision is by far the coolest. So building a robot and a pick and place system is quite an elaborate project for to get accomplished on the weekends. So I kind of broke it up into two phases, and the first phase will be the vision system, and then the future project, which will be done probably later on this summer, not during this class, would be to build the robot and other mechanical systems required by this. So the phase one is what I'm getting accomplished for this class, which would be the vision system. And here's kind of a schematic of how that is going to work. Parts will be presented to the camera, take an image. Are there parts there? If so, determine the brass type, the position, and the location within the frame. So I've got various different types of cartridges that I shoot. Like if anybody's familiar with guns, that shoot like the 223 Remington, 308 Winchester, and a couple others. So they're all fairly different. So I need to sort them by cartridge. So the overall plan, long term, I plan to use a Raspberry Pi and a Pi camera to do the image acquisition and processing, and then feed data to the robot on location and categorization of each piece of brass. For the short term, I developed a prototype system that was developed using just my DSLR digital camera, and then using MATLAB, since a lot less of a learning curve since I haven't used Raspberry Pis before. I I bought one and tried loading OpenCV and everything on there, and ran into a few hiccups, which will take a lot longer to get done. So I opted to build the system and get it up and running and learn some things before I dive deep into programming on the Raspberry Pi. The camera I used it's a 24 megapixel with 18mm focal length, and I got it set up on a tripod, basically looking down at the ground, and the my lighting and objects are located on the floor with a 4-foot distance between the camera and the stage that has the parts on it. And for this portion of the project, I didn't do any calibration. I am just relying on the distance away from the target and the large field of view to reduce my perspective error, which worked fairly well. The long-term project will be using the Pi camera, which has a lot more wide-angle lens, and so the distortion and perspective error will be a big concern. So I'll have to do camera calibration for that. I learned a few things about lighting on this project, so I wanted to touch on that for a bit before I get into the algorithms. The brass cases are cylindrical, shiny objects, so when you try and light them from above, you get hot spots in the image near the middle of the cases and along the edges, which induces a lot of variation into the process, depending on source light position relative to the target objects and the camera lens, which isn't very robust from a machine vision standpoint. These hotspots of intensity make it very difficult to extract and threshold meaningful data from the image for processing. I tried various angles of incidence to reduce this, but ultimately it couldn't be prevented using direct light given the nature of the objects I'm imaging. A little bit more about lighting here. In the industry, there's quite a few different ways people use lights to illuminate objects of interest, and a couple different ways are dark field versus bright field lighting. Basically what you're doing is, in a bright field, you're actually shining the light more straight down at the object, and light that is reflecting off of flat surfaces is reflecting back into your camera. When you have dark field, you shine a light at a much lower angle of incidence, and then light that bounces off of flat surfaces ends up going off away from the camera lens, and then rays that are bounced off of any edges and deep cuts or defects or things like that end up getting reflected back up into the camera lens. On the right here, you can see on the top picture of this Allen wrench set, when you use bright field light, you can't see anything in the image. It's really there's a lot of hot spots and you can't read the text. But then when you go to a low angle ring light, you can read the text really clearly, and from a machine vision standpoint, that's going to be pretty robust. So this was my first attempt at lighting, was to try a low angle ring light, and I'll show you that on the next slide. So this is pictures of the ring light that I tried to use. As you can see in the thresholded image, though, it didn't quite work out very well. You end up with some distortion along the edges and some missing features there, some missing area of that case due to the fact that the light is still reflecting off the sides and coming back up into the camera and causing hot spots. So the next option in my toolbox was to use backlighting, and this worked out really well, and ended up being what I used for my project. I went with the monochrome blue lighting because it's an opposing color to orange yellow on the color wheel, compared to my object of interest. That's the brass cases, so those are orange, and blue is opposite of that. So what that allows me to do is, when I read in this image into my algorithm, I can just ignore the red and green layers and just look at the blue. So it allows you to get a lot more contrast, and makes it very easy to threshold. And to build this, basically all I did was take a LED strips and put them inside of a cardboard box, and then use some almost like a white bed sheet on top to help diffuse the light. In the future, I'll probably use a sheet of polycarbonate to add some more rigidity so that the cases don't roll around so bad and fall down. So this is the beginning of the algorithm that I wrote in MATLAB. The first step that I did was threshold the blue layer and then convert it to binary so that it can be processed using the Vision toolbox. From there I use the blob analysis built-in functions in MATLAB to locate the centroids and find the areas of the object of interest. So the next thing I did was use that area data to classify the cartridges by cartridge type. So every cartridge that I reload is fairly different in volume, and thus different in cross-sectional area when I shine that backlight across it. So that worked pretty good to classify the different types. There were two that were very close in area, so if I get too much perspective error or other things like that, could cause classification errors. So if my case is located in the center of the image versus on the end, it could kind of mess that up. So I do need to do camera calibration to eliminate that, and I need to do more testing to see how reliable this is, because I was only able to test it a couple times. And then if the camera or the stage is physically moved, that'll kind of affect the results as well. So this is a good test algorithm, but in the future I'd like to make it more robust. And here are some pictures of the results that I plotted, and basically I output the image once with the classifications and bounding boxes around the objects, and then the second image is the location of the centroid of the objects, and then the angle relative to the horizontal axis here. So that data I could export out to my controller that controls the robot in the future when I build it, and then it can use that to locate and pick up the brass cases. And for this, I'm outputting the X and Y pixel coordinates. So when I do implement it with a robotic pick and place, I'll have to convert to real world coordinates and do camera calibration. So in conclusion, the project was successful from my standpoint of what I wanted to accomplish. My next steps are going to be to introduce camera calibration to help make the system more robust, and then also develop a more robust classifier. Using the areas works pretty good, but you know, it definitely probably can't handle the amount of variation that can be seen in a real world application like this. So once I get going on the mechanical side and find out what that system is going to look like and then I can get into the camera calibration for the actual application. And then next step 2 will be to build the system on the Raspberry Pi using OpenCV. Again, that ended up being a lot more complicated than initially expected, so I opted to do the system in MATLAB for sake of time and to learn as I went. So, thank you.